Okay, here we are on page 6, the amount of profit that's made by a company making MP3 players. Their profit is determined by the price of each unit. Okay, so they're saying it costs $120 to make each MP3 player. So keep that in mind, that the cost of materials and manufacturing and overhead and all that. The profit P the company makes is given by this equation. All right, well, I've typed that into the calculator. Profit is in millions of dollars, but the unit price is just in regular old dollars. All right, so you also want to keep that in mind. And I've got the calculator here with the equation typed in. I'm going to go to the window. Hopefully you can see this. If you think about this, X stands for the price in dollars, and we know that it's going to cost us $120 to manufacture it. So we're going to need to charge at least $120, but not like millions of dollars. So a typical MP3 player back in the day, maybe they're cheaper now perhaps. The minimum price that I'll show on my graph will be 0, but that's unrealistic. But the maximum price, let's say $400. That's well more than 120, but not insanely more. The skill that you're going to need to develop is coming up with real numbers based on the problem that you're given. If I say that it's in thousands, you might type in like 1, because that would represent 1,000. But it's in regular dollars, so to represent 400, we need to type in 400 for our dollars. The scale, just my ruler markings, I'll put them every 50. My Y is going to be a minimum of 0. And now the amount of profit that I might make is in millions of dollars. Well, it always pays to read the entire question, because sometimes I'll give away how many millions we might be expecting this to go. And here they're talking about the product being given away. Here they're talking about 120. Let's see, yet make a profit of $20 million, right? Major hint there that you're going to maybe go up to 20 million. So I'm going to say my Y maximum maybe will go to 30. And that's in millions of dollars, so I leave it at that. And the scale maybe every 5. So I go to graph. Hopefully something sensible will show up. Whoa, that's going way up. Oh, not way up. That's about right. So I need to see more up above to get that all in. So I'm going to go to my window and I'm going to make that 30 into 50. And I'm going to hit graph, and hopefully that'll show it all. And that's just about perfect. Okay, so I can simply sketch that graph right here. That's pretty boring, but I want to make sure I include the window. So I go back to my window. This is going from 0 in my X to 400 right there. It's going from 0 in my Y to 50, and this is million. Okay, and this is dollars, and this is the price I'm charging there. So profit and price. Okay, label your graph. Now, how much does the company lose if they give away their product for free? So that's if X is 0. Go back to your equation. That's when X is 0, they're giving away $71 million, losing 71 million. Okay. What is their profit if their player costs $120? That's not very well worded. If they charge, maybe it should have said. If they charge 120, that's their break even, so their profit should be 0. Does the above number make sense? Well, if I plug in 120 right here, I guess that's really what I'm asking. If I plug in 120, do I get 0? Let's try it. And if I go to my graph, and if I trace, and I trace back so that X equals 120, there it is. My price, my cost is about negative 50,000. If I go even just a little bit more, yeah, you'd need to get more accurate. You can do that by going to the table or whatever, but the calculator is showing approximately 0, and so yes, it makes sense. I'm not going to write a lot because I'm conscious of the time, but basically what that's saying is when I plug in 120 here, it agrees with me saying that it costs $120 just to make the thing. So if they charge what it's equal to make, that would be a 0 profit. What is the price of the player that will produce a maximum profit? Okay, this is like the most important part, so make sure you know how to do this. We're going to go to second, and trace gives us the calc. We're going to find the maximum. That's option number 4. I just need to have a left-hand boundary, and I'm bringing my X value, whoops, so I can at least see that it's on the left-hand side right there. So I want to make sure I'm the left-hand side of that bump, which I am, and I get the little pinchy arrow. I want to go to the right-hand side of the bump. I can be anywhere, so as long as I'm on the right, I definitely am. I hit enter a third time, and it tells me that the maximum is at $212.54. So you can just write that down, $212.54. If the company wants to charge as much as possible, yet still make a profit of $120 million, how much should they charge? Well, what I need is a line over here showing at $20 million. So I'm going to draw that. I'm going to go down and draw a $20 million horizontal line. And when I graph that, I'll see it there. I want to know what's this amount here, the most I can charge and make that profit. Okay? And so I would do intersect or trace, it doesn't really matter. I'll do second calc and I'll do intersect with number 5. And I'm going to get it close to that side so it chooses the better of the two intersection points. And I hit enter 3 times and it tells me at $265.63. So $265.63 is that one. Alright? Okay, we're jumping back to a different chapter here, or ahead to a different chapter. This is one of those conditional statements, if-then statements. If Achilles goes to the party, if you guys have been reading your Homer, you know about the Trojan War, Hector is not going. Not going is being the key. So that's in a symbolic forms. Achilles implies not H. Alright, that is the original form. We're calling that the direct form. So do we see anywhere down here that Achilles is going? We do not see that Achilles is going, so none of these down here are going to be direct. It might help you to immediately find the other one that's good, and that's when we say that if we negate this, what's the opposite of not H? That's H. That will imply the opposite of A, not A. So if Hector goes, then Achilles could not have gone. Hector did go, so Achilles did not go. That's this one then. So we would write this one is indirect reasoning, and this is valid. Now this is a hard section partly because the ins are used in indirect and inverse and invalid, and try not to get them confused, alright? But indirect is the opposite form. This is the direct form, and this is the indirect form. Okay, well what is this? This is Hector did not go, so Achilles did not go. Well, that's just nonsense. That is none of these, and it's not any form of these, so this is just nothing. And it says, if possible, identify the type as converse, inverse, or whatever. So this is invalid, and this is nothing. Achilles did not go. That's not Achilles, so Hector did go. Alright, that's if I were to change this and negate this and negate that. That's called the inverse. And the inverse, like the converse, does not work. It's invalid. Alright? So there are your best possible answers for those. And if you write the symbolic stuff like I did here and like I did here and like I could have written here, H implies not A, I'll give you partial credit if you just do that. So that would be a smart move. Alright, last page. Typical proof. Given parallelogram, prove that opposite sides are congruent. This is just like a summary of stuff we've already done. I'm going to draw a little sketch up here so I can get it all on camera. There's our parallelogram. If these are parallel and these are parallel, prove that the opposite sides are congruent. Really the best way is to draw an auxiliary line like this. And there's, I'm just going to use, let's see, A, B, C, D like this. So I'm just going to take this and put that down right there. That's given. Save myself time writing. Then down here I know that I want to have opposite sides. AB is congruent to CD. AB right here is congruent to CD right there. Well, I'm going to prove that these sides are the same by first proving that these triangles are the same, and those are going to be the parts. So I know it's going to be CP, CT, C. That's the whole basis. then I'm going to prove that triangle something is congruent to triangle something else and use like side angle side. Well, how do I do that? I can say angle 1 and angle 2 right there, they're alternate interior angles when these guys are parallel and this is the transversal. Okay, so right here I'm going to say angle 1 congruent to angle 2, and that's AIA angles are congruent. You can just write AIA. Then here's angle 3 and angle 4. They're also congruent for the same reason. I'm just going to use quote marks. And then this side is congruent to itself. DB is congruent to BD, and that's the, well, duh, or reflexive property. And then the triangle ABD, ABD, ABD is congruent to triangle CDB, CDB, and that's angle, side angle, angle, side angle, and then CPCTC. You might have wanted to squeeze a little step in there where you draw side DB. That's your auxiliary line. But if you didn't include that step, I wouldn't take off for it, because you're allowed to draw lines between any 2 points. And that's it. That's the test. Good luck.